Okay, 3. Okay, I'm recording now. All right. So a 50-gram mass is attached to a spring and it is set to perform simple harmonic motion with amplitude and period. Okay, everything is given the maximum speed and acceleration. Okay, so actually this is also an easy question lah. Okay, so we have mass already. We have amplitude, A. But be careful of the unit. The gram, centimeter. All this you must change. And then period, this is period. Okay, this is about simple harmonic motions, SHM. Okay, so A1. Okay, how to do this? Maximum speed, we want to find V. Okay, want to find V max and A max. So how to find V max and A max? So V max is still remember Y max displacement, Y max is amplitude, V max is A omega, A max is A omega square. Remember this? Amplitude omega square. Yeah? Y max, V max, A max. Okay, so you need to give this V max and A max. So calculate. You already have the Y max. You see, 12 cm. Okay, maybe you can write it down. Okay, amplitude already have, but convert to meter. 0.12 meter. That's the Y max amplitude. Then V max is A omega. V max is A omega, 0.12 meter multiply omega. Oh, omega you need to find first. Omega you need to find because you got period. So omega, okay, find omega first. Omega is 2 pi f ataupun 2 pi over period. You have a period is what? Your period is 1.7 second. 1.7. So 1.7. So what is the answer? 2 divided by 1.7. It is okay. So okay lah, maintain, cannot divide, so maintain in in fraction form first. Okay, so yeah, that's the omega. So 20 omega is 20 pi over 17. So what's the answer? What's the answer? So let's calculate. 20 pi divide by 17 and then multiply by 0.12. Okay, I got answer 0.44 meter per second. That's the answer. Okay, and then how about maximum acceleration? Maximum acceleration is A omega square. So I get what? Okay, so I get 20 pi divide by 17 and then square multiply 0.12. So the answer is 1.64 meter per second square. Okay, very simple. Okay, so how about the next question? So question B. Question number 2. Speed of the mass when displacement is he give you displacement. You need to find speed V. He give you displacement already, Y. Displacement. So use what? V versus Y equation. Remember? V equal to plus minus omega A square minus Y square. Okay, class?
Yes, sir.
Speed, actually speed just the magnitude lah. No need the sign positive negative. Speed because it's scalar quantity. It's scalar quantity, so no need the positive negative. Yeah, no need the positive negative is the direction. Yeah, so for scalar quantity like speed, no need the direction lah. Yeah, no need the positive negative. But If you put positive negative, we don't penalize you. Yeah, it's considered something extra information. Yeah, we don't penalize for extra information. Yeah, don't worry. If even you put positive negative, yeah, don't worry. We don't penalize marks. Okay, so omega is 20 pi over 17, and then amplitude is 0.12 square minus displacement given is 6 cm. So you must change the unit must change not cm must change to meter so 0.06 square, yeah, divided by 100. Okay, so you can find already the answer is the speed is what 0.12. You know, press calculator from inside first, then you go outside. 0.12 square minus 0.06 square, and then square root the answer. Okay, and then multiply by 20 pi divided by 17. So the answer is 0.384 meter per second. That's the answer, 0.384. Okay. Next, all using formula only lah, very easy. Yeah. The kinetic energy and potential energy of the system when displacement is give you displacement. Yeah. You need to find kinetic energy and potential energy given the displacement again. So you use what? Kinetic versus. You see, got two answers you need to give. In one question, you got two answers you need to give. So be careful. Got two answers. Read the question carefully. So you use the kinetic energy displacement formula and potential energy displacement formula. Okay. So question 3, use the kinetic energy versus displacement formula, and then later on use potential energy versus displacement formula. Still remember? Kinetic energy versus displacement formula. Kinetic energy is half m omega square a square minus y square. Okay? Because you know why? Because kinetic energy is half mv square. Understand? Half m v square. The v just now is what? The v just now, the v over here is v equal to plus minus omega. The v here is plus minus omega square root a square minus y square. So now your v kena square. This one kena square. You understand? Ini square, lepas tu ini kena square. Kena square. So ini kena square dapat apa? Dapatlah ini. Dapatlah ini. Understand not, class?
Understand, sir.
Your v square, so square this whole thing, then you get this. You see omega square, then the square root also gone. The square root also gone. That's how we derive lah. Okay. Then potential energy formula is what? Potential energy formula is half kx square. Half kx square. You know the elastic. This is elastic potential energy. Remember elastic potential energy. And then k is m omega square. Remember that? K equal to m omega square. So that's why. So half potential energy formula is half m omega square a square. No. Sorry. Half m omega square y square. So sorry, the formula is half k y square because we're using displacement view symbol, we use y, not x. Wow. So k is m omega square. So k substitute m omega square. So become half m omega square y square. You know, this is elastic potential energy. Remember that? You remember elastic potential energy half kx square. X we change to y. For kinetic energy is half m omega square a square minus y square. Potential energy is half m omega square y square. Just the y square. Okay, so that's a formula. Okay, just use formula. All these formula given in the list of formula. Okay, but actually it's better if you know how to derive. Yeah, then the physics more meaningful to you. Yeah. Okay, never mind. Yeah, so let's continue. So this one is half mass. Mass is what? Mass is 50 grams. So change also. 0.05 kilogram. Yeah, divided by 1000. So omega is what? Omega is, just now is 20 pi over 17. 20 pi over 17. 20 pi over 17 square, and then amplitude. Okay, this one I need to write it somewhere. Not enough space for me. Okay. And then what? Amplitude is what? 0.12. Yeah, all these are formula only lah. Yeah, formula only. So y, what is the y given? 6 cm. Also change to SI unit divided by 100. So it's 0.06 square. So your kinetic energy at that displacement is, calculate lah, square and then minus 0.06 square, and then multiply by 20 pi divided by 17 square, multiply 0.05 and divide by 2. So 3.69 exponent negative 3 joule. Okay, easily got the answer. And then what is the rest? Mass is for potential energy. What is that? 0.05. And then omega is 20 pi over 17 square, and then y. What is the y here? Yeah, 0.06 just now, isn't it? 0.06 square. Okay, so what is the answer? Let's check. 0.6 square multiplied by 20 pi divided by 17 square multiply 0.05 divided by 2. So I got the answer 1.23 exponent negative 3 joule. Okay, that's the answer. Now, what is the total energy? Good. What's the total energy of the system? I expected this question will come out. Total energy. Later I will show you one special things here. Okay, total energy formulas, remember? Total energy formula is half m omega square amplitude square, isn't it? Amplitude square. So okay, what's the mass? 0.05 because it's 50 gram. Yeah, 50 gram. And then omega, what is omega? Omega is 20 pi over 17 square. What's the amplitude? Amplitude is 0.12 square. So answer, what's the answer? 0.12 square multiply 20 pi divided by 17 square multiply 0.05 and divide by 2. So answer I got 4.92 exponent negative 3 joule. Okay, is that answer? Okay, you see, just now the question 3 asked for kinetic energy and potential energy when displacement is 6 cm, isn't it? So at 6 cm, the kinetic energy is this. Yeah, at 6 cm, that's the kinetic energy. That's the kinetic energy. And then at at 6 cm also, that's the potential energy. That's the potential energy. So what's the total energy? Maybe you can add up these two. Add up these two. Kinetic energy plus potential energy equal to what? Let's try add up. 3.69 exponent negative 3 plus 1.23 exponent negative 3. And what's the answer you get? 4.92. Apa ini maksudnya? That means is equal to the total energy, isn't it? Betul tak?
Yes.
Okay?
Yeah.
Yeah. Actually, if you plus up these two, ini tambah ini, dia cuma buang yang ini bah kan? You just cancel this and cancel this bah. So you end up still is half m omega square a square bah kan? You still left with half m omega square, which is you know, half m omega square a square, which is inilah betul. Faham ke? Negative. So actually, the total energy, kinetic and potential energy, it's just interchange. Simple harmonic motion, you know, the spring mass system oscillation. It just interchange between potential energy, kinetic, and then kinetic change to potential, potential change to kinetic, kinetic change to potential, potential change to kinetic. It just interchange the conservation energy. Energy is conserved. So the total energy is always the same. Total energy is always the same. K plus U equal to total energy, and total energy is always constant in the oscillation, in the spring mass oscillation. Yeah. Okay, it's always constant. Okay lah. Draw on the same graph, sketch and label both kinetic energy and potential energy versus displacement for the 8A. So okay, so yeah, this one graph already have the inside the node, isn't it? But okay, you must label. Important thing is not just sketch, you must also label. Sketch and label. Label means you must have what? You must have the what? You must have you know, the label the values, label the symbol at axis and unit. Not just sketch only, you must also have the values, or the total energy you get just now and the amplitude value you get just now, you must also put in the graph. Understand not? Okay, let me draw. Let's draw the graph. Yeah, it should be something like this. Total what form graph? Kinetic energy and potential energy versus displacement formula. Versus displacement. Okay, so that means I want to draw a kinetic energy or potential energy. Potential energy. You just put like Ku and also total energy lah, and also total energy we can draw also. So joule. What this is the Y displacement. This one in meter. You must have the unit. Unit mesti ada. Tak boleh tiada unit. So lepas tu ini negative amplitude, ini positive amplitude. Amplitude berapa tadi? Mesti ada value 0.12. Positive 0.12. Is it 0.12? Yeah, 0.12 meter. And then this one is negative 0.12 meter. Must put here. The SI unit must put over here, and then here is the total energy. Here actually is the total energy, which is half m omega square amplitude square. Understand? Amplitude square, which is what? Which is what value just now? We got 4. This value over here is 4.92 exponent negative 3. 4.92 exponent you want to put at the top here also can. Exponent at the top, but never mind lah. Just put everything over here. Negative 3 joule. You want to write unit here better lah. Yeah, unit here so that you won't. Okay, some more. So how is the shape looks like? How's the shape looks like? Potential energy. Potential energy is 0. You know, potential energy at equilibrium. Equilibrium 0. At equilibrium, no extension, no compression. No extension, no compression. U 0. At amplitude, extension, and compression maximum, isn't it? Betul tak? So that means this is the potential energy from graph. Very hard to draw. Potential energy graph. You plot first lah, then you draw. This is the potential energy graph. Correct or not, class? No extension, potential energy 0. At maximum extension, potential energy maximum. Then if potential energy 0, where's the energy gone? Where has the energy gone? It go to the block. The block gain the maximum kinetic energy. The block has the maximum kinetic energy at the equilibrium. And then we go to the amplitude, the block stop for a while. So kinetic energy 0 at the amplitude. Maybe use another color lah. Yeah. What color can I use? Maybe purple. Yeah. So understand, class? This is the kinetic energy graph. Kinetic energy of block becomes 0 at the amplitude because it stopped for a while, changing direction, isn't it? But at equilibrium, the block moves fastest, maximum speed, has the maximum kinetic energy. Okay, at last, this is the total energy graph. Total energy graph. So it's always constant at all displacement, at all time. Total energy graph. And the value is over here is 4.92 exponent -3. You must have this value. Understand, class? Okay, that's all for this question. So let's check the answer. Is it correct? So question what? Question 8. Question 8. Let's check question 8. Oh, what happened? Oops. Let's check question 8. Oh, what is this? Question 8. A1, yeah, A1, maximum speed. It asks you to find maximum speed. Why got so many? 0 point. Okay. Period. Use a long method. Never mind. Okay. So we got V equal to 0.44. Correct? Correct. Acceleration maximum negative. Actually, no need negative lah. Yeah? No need negative. Because maximum acceleration, just the magnitude. Yeah. Because it can be, acceleration can be positive, negative. Yeah. Depend on where is the block. Yeah. You understand, class? Because the block, if the block is over here, yeah, or over here, yeah, this y positive, this y negative kan. So you look at here. So if at this position A is negative, if at this position A is positive, see that? Both are maximum. Both are A maximum. So here A negative, here A positive. So this question asks for maximum acceleration. It doesn't mention which amplitude kan. So it doesn't specify which magnitude. So actually it just want the magnitude only. Yeah, just want the magnitude only. So no need to put the negative sign. Okay? No need the negative, just the magnitude only. Yeah, maximum acceleration. So it can be negative, can be positive. Yeah, depend on which position. So this is just put positive value. Yeah. So ignore the negative sign. If you put negative sign, we also just accept lah, yeah, because it's from the formula negative omega square y. Yeah. Okay, just magnitude. Understand, class? Yeah. And then our number 2, so V is 0.384, 0.386. A little bit different, never mind, because just now their omega is more more accurate. Our omega is not to in fraction. Ours are more accurate. So a bit different, never mind. 0.384, 0.386. See, they don't have speed, don't have the direction, positive, negative. Just magnitude only. Okay. If velocity, then yes. Velocity, then you need to put positive, negative. Kinetic energy, kinetic energy is 3.69, negative 3. Yeah, correct. And then 1.23, negative 3. Correct. Potential energy. Yeah. And then the graph is total energy is 4.92, negative 3. Correct. And then that's the... See? Correct or not? My graph. This is the kinetic energy. 0.12. See that? Potential. This is a potential energy graph. U. Okay. U. Then kinetic energy graph. See that? Kinetic energy. And then this here is 4.92. 4.92, negative 3. Okay, class. Understand, class? Is correct everything, yeah? So that's the way lah. You answer like how I answer. You answer like how I answer, then you can get full mark. Get A for your physics. Okay.